Ever get a little creeped out thinking about being stuck in a cramped space, like way underground?
Can't say I love the thought.
Right. But now imagine you're not just stuck, you're depending on a complex system of fans and vents for each and every breath.
Okay, now you're just trying to make me claustrophobic.
Maybe a little, but that's the reality for thousands of miners every day, and it's all thanks to the incredible work of mine ventilation engineers. We're diving deep into their world today.
It's a side of mining most people don't even think about, but it's absolutely essential.
Totally. We've got this career guide you send over, and it calls these engineers the masterminds behind a mine's entire ventilation system. And honestly, after reading through this, mastermind feels pretty accurate.
It's incredibly high-level stuff. This isn't just about keeping the air fresh, though that's obviously crucial. They're managing airflow, temperature, humidity, even controlling for dust and potentially dangerous gases.
It's like they're controlling an invisible force that's literally keeping everyone alive down there.
Exactly. And the what they do section of this guide really gets into the depth of knowledge these engineers need. It's not just about airflow, it's understanding the entire mining operation, the equipment, the extraction processes, even the specific minerals being mined.
Wow, so they're taking all of that into account all the time.
Absolutely. They're basically predicting the future down there, anticipating potential hazards before they happen, and designing systems to prevent them.
That is wild. And what really stood out to me was how much collaboration is involved. I mean, this guide mentions working with everyone from mine management to safety engineers to planning engineers. That's a lot of moving parts.
It's a huge team effort, and for good reason. One miscalculation or miscommunication could have serious consequences.
Okay, yeah, that's what I was thinking. Are we talking constant debates about the best airflow strategy? Because one wrong move underground.
You're hitting on a really important point, and the guide actually addresses this directly in the typical interaction section. It emphasizes that while technical expertise is obviously critical, so are communication and teamwork. Everyone needs to be on the same page, literally, to make sure everyone underground can breathe easy.
It makes you realize how much we rely on this unseen expertise even in our everyday lives. We benefit from the products of mining all the time, but we rarely think about the people working behind the scenes to make it all possible.
Exactly. And when you factor in the inherent risks of mining, the role of these engineers becomes even more significant. They're not just ensuring efficiency, they're ensuring people come home safe every single day.
You know, one thing that really surprised me in this career guide was the job outlook for mine ventilation engineers. They're predicting 4% growth over the next decade, which honestly, with all the talk about automation and robots taking over
Hey,
everything,
you'd think this would be one of those fields that's shrinking.
exactly, like robots go underground, problem solved, right?
Right. But it turns out it's not that simple. And this is where it gets really interesting. The industry trends section of the guide actually links this job growth to a couple of key factors. One being stricter safety regulations in mines around the world.
Which makes sense. The more emphasis there is on safety, the more you need people who can actually make those environments safe.
Exactly. And the other factor is this global push for more ethical and sustainable mining practices. Companies are really feeling the pressure to be more responsible, and that includes how they treat their workers. And that's where skilled ventilation engineers become even more important.
So it's almost like a paradox, right? The more technology we throw at the problem, the more we need human expertise to make sure it's all being used responsibly.
Exactly. It's a fascinating dynamic. Technology can definitely improve safety and efficiency in mines, but it's not a magic bullet. You still need skilled professionals to design those systems, implement them, monitor them, and make sure they're actually achieving the desired outcomes.
That makes a lot of sense. So let's say someone's listening to this and they're intrigued by this whole mine ventilation engineer thing. They're picturing themselves, hard hat on, descending into the depths. What would they actually need to do to get started? Is it all mining degrees or?
Well, a solid understanding of mining principles is definitely helpful. But you're right, it's not the only path. The academic pathways section of the guide emphasizes that a bachelor's degree is kind of the standard entry point. And while mining engineering is an obvious choice, there are other avenues as well, like environmental engineering.
Environmental engineering. That's interesting. I can see how that would be relevant with air quality and all that.
Exactly. And then there's mechanical engineering, which makes sense when you think about all the machinery and equipment involved in ventilation systems.
And then there's one more that might surprise you. Geology.
Geology. Wait, hold on. We're talking about air, right? What does the Earth have to do with any of this? It's all connected. Remember, we're talking about working in underground environments, and geologists bring that crucial understanding of rock formations, soil mechanics, how different geological conditions can impact airflow, and the stability of those underground spaces.
Okay, now that you mention it, that makes a lot of sense. I never would have thought about it that way. So it's a very multidisciplinary field, which I guess makes sense when you consider all the factors at play.
Absolutely. And that's one of the things that makes it so interesting. You're not just dealing with one aspect of the mining operation. You're considering the entire ecosystem down there.
So we've got the education part down, but what about the day-to-day reality of the job? I was looking at this pros and cons section, and one of the cons listed was remote work locations. Now I'm picturing a zero Zoom, zero meetings kind of work environment. Am I way off base here?
Well, you're not wrong about the remote part, that's for sure. But maybe not in the way you're thinking. While some office work is definitely involved, especially in the design and planning stages, this is a job that requires a lot of hands-on experience. You're going to be spending a significant amount of time on site in the mining environment.
So less about comfy office chairs and more about hard hats and headlamps?
You got it. And you have to be comfortable with that because we're talking about potentially hazardous conditions, physically demanding work, being underground for extended periods. It's not your typical 9 to 5.
Okay, so let's say those hazardous conditions don't scare me off. I've got my hard hat, I've got my steel-toed boots. I am ready to embrace the life of a mine ventilation engineer. What does that actually look like day to day? Am I like
Right.
immediately thrown into the deep end designing ventilation systems for these massive underground operations?
Well, not quite. It's not exactly trial by fire down there.
Yeah.
Though I'm sure there are some pretty intense moments. This is a movie where you just jump into the action hero role. The guide actually has a whole section on mine ventilation engineer career stages. And it lays out a pretty clear progression.
Uh-huh.
You're not drafting solo missions on day one. It starts with entry-level positions working under more experienced engineers.
So more like an apprenticeship.
Exactly. Learning the ropes, getting a feel for the real-world challenges before you're even close to calling the shots.
Okay. No pressure to single-handedly save the mine on my first day. That's good to know. But what kind of tasks would a newbie, let's say a junior mine ventilation engineer, actually be doing? I'm looking at this list, and one of them is perform computational fluid dynamics, CFD modeling to optimize airflow distribution. Okay, be honest, is that just a fancy way of saying playing super high-tech video games all day?
I wish. Though it does sound kind of cool when you put it that way. It's definitely high-tech, but it's not exactly a game. Imagine being able to build a virtual wind tunnel on your computer. That's essentially what CFD modeling lets these engineers do. They can test out different ventilation designs, different scenarios, all in this digital space before a single piece of ductwork is installed underground.
Wait, so they can actually see how the air will flow, where the potential hazards might be, all before anything's even built?
Exactly. It's like having a crystal ball,
Yeah.
but for airflow. It's all about predicting how the air will behave in that specific underground environment. And that's crucial, not just for safety, but also for things like energy efficiency. By optimizing those ventilation systems, they can minimize energy waste, which is good for the environment and for the mining operation as a whole.
It's amazing how much detail goes into this. It's like you don't even think about the air you're breathing until someone points out how much work goes into making sure it's breathable.
Right. It's one of those things we take for granted. And that's kind of the story of ventilation in general. It's this essential aspect of mining, but most people never even think about it.
Exactly. And that's what we love about these deep dives. We get to go beyond the surface, uncover the hidden complexities, and appreciate the often unseen expertise that keeps things running smoothly. Or, in this case, keeps the air flowing. So to all our listeners out there, next time you think about mining, think about the mine ventilation engineers working behind the scenes to keep those underground spaces safe and operational. It's a career path that doesn't always get the spotlight, but it's definitely one that deserves our respect. And with that, we'll wrap up this deep dive into the world of mine ventilation engineering. We hope you learned something new today and maybe even gained a new appreciation for the air you're breathing.